Alright, here we are in part F, limits involving infinity. Well, let's get rid of that. Alright, the first couple of problems are the easiest type. If x is approaching infinity, then we get to channel our horizontal asymptote rules. And for horizontal asymptotes, you look at the degree on top and bottom. And in number 12, the top degree is equal to the bottom degree. And if the top and bottom degree are equal, which they are, then you divide the leading coefficients, which in this case is 3 and 2. So the answer to number 12 is 3 over 2. And you just leave your answer like that. Not a whole lot to work to show there. Now I suppose if you wanted to fight for partial credit, you could do exactly the kind of scratch work I did here. So if you happen to mess it up, then I can see that you were at least trying to do the right thing and might get a point or two for that. But if all you write is an answer, then it's either all or nothing in those cases. 13, again, it's approaching infinity, limit is, so you look at degree on top and bottom, and in number 13, our bottom degree is greater than the top degree. And if that's true, if that's the case, then the answer is 0. Therefore 0. So your answer is 0 because my bottom degree was equal to the top degree. Over here, I guess I'll write this in. If the top and bottom degree are equal, you divide the coefficients. Therefore divide coefficients. Alright. Number 14 is a little bit different. This time we are not approaching infinity. This is approaching 2 from the right. So do not look at the degree on top and bottom. We're not going to be able to use that here. On 14, what I will start by doing, since I am approaching a number, I will simply plug in that number. 3 times 2 is 6, plus 1 is 7, 2 minus 2 is 0. And in limits, if you ever get a number divided by 0, it could be one of 3 things. Your answer could be infinity, your answer could be negative infinity, or the answer is does not exist. And we have to figure out which of those 3 it's going to be. So in limits, if you get a number divided by 0 after you plug in, then you're looking at one of these 3 cases. And the way we figure it out is I'm coming from the right side of 2. This is coming from the right side of 2. So I plug in a number that's just on the right side of 2. Now, you'll probably be okay if you plug in 3, but I like to stay really close to 2. So I'm going to plug in something like 2.1. And all I care about is whether I get a positive or a negative. So if I do 3 times 2.1 plus 1 over 2.1 minus 2, 3 times 2.1 plus 1 will give me a positive number. 2.1 minus 2 will give me a positive number. A positive divided by positive is positive, and that tells me that this answer is going to be positive infinity. So therefore, this, this limit equals infinity. So there's your answer for this one. If I plugged in something and I got a positive over a negative, then the answer would be negative infinity. So there's 14. Let's see, 15, approaching 1 from the left. Same type thing. I'm going to start by plugging in 1. 1 squared is 1. 1 minus 1 is 0. And again, I have a number divided by 0. And a number divided by 0 means you have to look just to, in this case, the left side. So I'm going to look at the left side. So I need a number on the left side of 0. Now I would plug in 0.9 because that's just the left side of 0, left side of 1, because 0.9 is just on the left side of 1. However, some of y'all are probably going to want to plug in something like 0. And I want to show you what happens sometimes when you plug in the next whole number instead of just going just a smidgen to the left. If I plug in 0, I get 0 squared, which is 0, over 0 minus 1. And 0 over negative 1 is 0. You don't get a positive or a negative answer. This doesn't help you with the answer to the limit. So this actually fails. That failed. So for reasons like that, you don't want to get too far away from what the limit is approaching. So I'm going to plug in something just to the left side of 1, like 0.9. If I plug in 0.9, I have 0.9 squared over 0.9 minus 1. If you square anything, you'll get a positive answer. 0.9 minus 1 will give you a negative answer. Positive over negative is negative. Therefore, this limit equals negative infinity. Okay, number 16. Limit is approaching infinity, so this is another one where you get to look at the degree on top and bottom. And in this case, my top degree is greater than the bottom degree. And if your top degree is greater than the bottom degree, that means your answer is either going to be infinity or negative infinity. And the way you determine whether it's positive or negative is you think, alright, x is approaching a huge positive number, and I want to know whether this fraction is going to be positive or negative. Now, I'll look at the powerful terms. My powerful term on top is 3x to the 4th. Plus 7 isn't going to matter much. If I have 3 times infinity to the 4th power, adding 7 to it isn't going to make a difference. Same thing on bottom. If I have infinity squared, adding 3 to infinity squared is not going to make a difference. So when I plug in a huge positive number, I have 3 times infinity to the 4th over infinity squared. And when you look at that, 3 times a huge number to the 4th, that's positive. A huge number squared is also positive, and a positive divided by positive is positive. Therefore, this answer is positive infinity. And you do that if the top degree is bigger than the bottom and your limit is approaching infinity. You only use the degree rules if your limit's approaching infinity or negative infinity. Number 17, I'm approaching 0, so I'm not going to look at degree on top and bottom. I'm going to plug in 0. I get negative 9 over 0 squared. And again, here I have that number over 0. So for this problem, I'm going to have to look at it and plug in numbers real close to 0 like I did on number 15. The difference is here I didn't specify one side or the other. I simply said 0. This means we have to look at both sides and see if both sides agree with each other. So let's start by looking at the left. A number just to the left of 0 would be something like negative 0.1. And if I plug in negative 0.1, I have negative 0.1 minus 9 over negative 0.1 squared. Negative 0.1 minus 9 is negative. If you square anything, you'll get a positive. A negative over a positive is negative. Therefore, my left side is approaching negative infinity. And that's important. So we're going to put that on hold for a minute. And now I need to look at the right side of this limit. Let me give myself a little bit more room here. Alright, so let's look at the right side. Okay, something on the right side of 0 would be something like 0.1. And when I plug that in, 0.1 minus 9 over 0.1 squared. 0.1 minus 9 does go into negative numbers. 0.1 squared is positive, and negative divided by positive is negative. Therefore, my right side also is approaching negative infinity. Okay, so once I look at the left and the right, then I'll look at them and I want to know, did they go to the same place? Do I have the same answer? If I do, then that's the answer to our limit. And in this case, left and right are both going towards negative infinity. That means that the limits do agree. That's what you call it. Say the limits agree. And since they do agree, therefore, the limit as x approaches 0 from both sides of my function, x minus 9 over x squared, does equal negative infinity. If I got different answers for left and right, then our overall limit would just not exist. You need to have a does not exist case, which is one of the candidates. Remember I said if you have a number over 0, it's either infinity, negative infinity, or if both sides disagree, does not exist. Number 17 happened to be negative infinity. So there are your infinite limit cases.